Heating consumption analysis divides the facility's heating consumption into three parts: ventilation heating, domestic hot water heating, and base load. In order to work, the report requires the following measurements and basic building data: hourly district heating measurement, building type, surface area, volume, and construction year. Hourly water metering is also recommended. The key results of the analysis are shown in the summary at the top of page and in the table below it. Using the columns menu above the table, you can add or remove information displayed in the table. After the facility names in the second column, you find icons for downloading the facility report, creating actions, and updating analyses. The state column indicates whether the analysis was successful and provides potential reasons for any failure. The status column shows the status of the findings, which you can update using the pen icon. From the date column, you can see when the calculation was last updated. Actions column shows if an action has already been created from heating consumption analysis for the facility under inspection. Subsequent columns display the identified saving potential and results of the analysis. The baseload column shows the heating base load of the building per square meter at an outdoor temperature of 0 degrees Celsius. If the building has continuous ventilation around the clock, it is included in the baseload. In the next column, you can see the ventilation power per square meter during the building's usage hours, also calculated at an outdoor temperature of 0 degrees. The values in brackets show the reference values for base load and ventilation of the building type in question. Savings potential is calculated by comparing the results to these reference values. So if the results show higher values than the reference, there may be potential for savings. Specific water heating power column shows how much heating power per square meter on average is used to heat water. In the last column, you can see the total average heating power of the building at 0 degrees. For some facilities, not all values can be found, which means that the proportion of ventilation cannot be identified from the consumption data. These are typically facilities where ventilation is always on at a constant power. However, for these facilities, it is possible to make more detailed analysis of the consumption of domestic hot water. Next, let's go through the content of the facility report, which you can access by clicking the Download Report button. In the abstract, you can see a table where the level of different components of heating power, reference values, and savings potential are presented. Heating distribution section shows how the heating consumption is divided between ventilation, hot water heating, and base load in the facility. If there is ventilation on during night time, it's included in the base load. In the next graph, you can see the daily distribution of heating consumption. The daily consumptions are normalized to 0 degrees to make the results comparable. This allows, for example, detecting if there has been changes in the level of any heating energy component. Changes and adjustments and settings of the heating system can be seen as changes in the base load or ventilation levels. Heating distribution interweek graph shows how the heating energy is distributed on an hourly basis within a week on average. The reference lines indicate the level of energy consumption in a typical building of the same building type. There are two reference lines for ventilation, which indicate the range in which the heating energy consumption of ventilation is typically when the air volumes are at a normal level typical for the facility type. High ventilation heat consumption could indicate that the heat recovery of ventilation is poor, air volume is higher than normal, or the temperature of ventilation air is unnecessarily high. You can also see how the power levels of the ventilation vary on business days and weekends. High base load compared to reference can be a sign of ventilation running on partial power constantly, or that the building's insulation is not as good as on average in similar buildings. In facilities where ventilation is on at a constant power, it is possible to determine the energy efficiency of domestic hot water heating. In a normal scenario, about 58 kilowatt-hours of energy is used to heat 1 cubic meter of water. This is shown as a green reference line in the figure that shows the correlation between the water consumption in the facility and the temperature normalized heating energy. The second line in the figure is the correlation between the water consumption in the facility and the consumption of heating energy. If the regression line is higher than the reference line, it is recommended to check the domestic hot water heating settings. In this case, the regression line is lower than the reference line, which means that less energy is used to heat the hot water than in the reference facility,